Namaste, my dear students. Welcome back. It's your favorite science teacher here, and I know those final exams are right around the corner. But don't you worry, because today I'm going to make sure you score a perfect 100 out of 100 on Chapter 8, Soil. Chalo, let's dive right into this explainer.
All right, here is our roadmap for today. We're going to break this chapter down into 6 exact parts: the birth of soil, factors shaping soil, the soil profile layers, composition and porosity, sandy, clayey, and loamy soils, and finally, the 3 properties of soil. Stick with me, and I guarantee you'll remember every single detail.
Let's jump right into part 1, the birth of soil. I mean, how does this stuff actually form in the first place?
Now, you absolutely need to know these 2 definitions for your exams, so pay close attention. First, soil is the uppermost layer of the earth, right? But it forms through a very slow process called weathering. This is basically the continuous breaking down or disintegration of rocks by natural forces. Think wind, water, frost, and even plant roots pushing through the cracks. Now, weathering breaks the rock, but it's humus that actually brings it to life. Humus is just the dead and decayed plant and animal remains. It's literally the magic ingredient that makes our soil fertile.
Okay, mark this in your notes as VVI. Very, very important. You are almost guaranteed to see a difference between question on this: physical weathering versus chemical weathering. Now, what's really interesting here is the contrast. Physical weathering is just a mechanical process. The rock breaks into smaller pieces because of temperature changes, frost, or roots, but there is absolutely no change to the actual characteristics of that rock. Chemical weathering, on the other hand, breaks the existing minerals into entirely new mineral components. The chemical nature actually changes, and water is the main agent driving this. Make sure you get that down.
So, let's walk through this like a little story. How does a rock become a garden? In stage 1, the large chunks of the parent rock disintegrate because of that weathering we just talked about. Then, in stage 2, those broken rocks weather even further into finer particles. This is where the bacteria and microorganisms show up to the party, breaking down organic matter and adding our best friend, humus. Finally, in stage 3, minerals and salts seep deeper into the ground with the rainwater. And just like that, step by step, the parent rock becomes a perfect fertile bed for plants to grow. Makes sense, right?
Moving on to part 2, factors shaping soil. We know how it forms, but what natural forces actually decide how fast that happens and what the soil looks like?
There are 3 major players you need to memorize here. First is climate. Soil formation is fastest in hot, moist climates. Why? Because warm, wet tropics have super high bacterial activity, which means lots of rich humus is being created really fast. Conversely, it's incredibly slow in cold, dry climates or deserts where there's barely any vegetation. Second is the parent rock. This is like the DNA of the soil. It determines the composition. If your parent rock is full of calcium, your soil is going to be full of calcium. Simple logic. And third is the slope of the land. Hilly areas usually have a very thin layer of soil because running water and wind just wash it straight down. But down on the flat plains, the soil just sits there undisturbed, building up into a really nice thick layer.
All right, part 3, the soil profile layers. We are going to look at the Earth from a totally different angle now.
Imagine we take a giant knife and just slice the ground open vertically, exactly like a huge cake. That side view, that is what we call a soil profile. It's a vertical section of soil from the ground surface all the way down to the parent rock, showing the different, well-developed layers. And in your science exams, you need to use the proper term for these layers, which is horizons.
Now, this table is heavily tested beta. You need to remember the order. Just use this simple mnemonic. O, A, B, C, R. Let's go through them. O is for organic, sitting right at the very top, rich in organic matter. A is your topsoil. It's the uppermost layer we usually see, dark, soft, porous, holds water well, and is packed with humus. B is the subsoil, which has compactly packed fine particles and is full of seeped minerals. Then we hit C, the weathered zone. This is partly weathered rocks with cracks and crevices. It is very hard to dig through. And finally, R is for bedrock. So, the crucial point is that this lowermost R horizon is the parent rock, and it literally determines the properties of every single layer sitting above it.
Let's shift gears to part 4, composition, air, and water. Time to zoom in and look at the microscopic ingredients of our soil.
So what is a scoop of soil actually made of? The main constituents are water, sand, clay, silt, pebbles, and humus. You might remember that really fun textbook activity for this. If you take a handful of garden soil, mix it up with water in a glass jar, and just let it sit entirely undisturbed for a couple of hours, you will literally see these exact constituents settle out into perfectly separate, distinct layers right in front of your eyes.
Listen up, class, because examiners love pulling multiple-choice questions from this specific table. You absolutely must memorize these numbers. The size of these particles is what defines our soil types. Clay is the absolute smallest. Its particle diameter is less than 0.002 millimeters. Tiny. Then it goes up to silt, then sand, then fine pebbles, medium pebbles, and finally coarse pebbles, which can be massive, up to 75 millimeters across.
And particle size leads us directly to a very vital concept, porosity. Porosity is simply the amount of empty spaces or pore spaces between the soil particles. Now you might be wondering, why do we care about empty space? Well, because those pores get filled with air and water, and plants' roots desperately need that trapped air and water to survive. The golden rule to remember here is, larger particles mean larger pore spaces between them.
Okay, moving into part 5. This is the big one, guys. Sandy, clay, and loamy, the 3 major types of soil.
Pay close attention, because this is your most important topic for those long essay questions. How do we easily tell these 3 soil types apart in real life? We use the hand test. Visualize yourself in a garden doing this. Grab a handful of soil, wet it a little, and roll it between your fingers. If it feels super gritty and looks pale brown, that's sandy soil. If it forms a shiny, smooth, sticky coating on your hand and is grayish-brown, you've got clayey soil. But if it feels flaky and looks dark, congratulations, that is loamy soil.
Let's break down this massive comparison table together. Sandy soil is more than 2/3 sand. Because it has large particles, it has large air spaces. This means low moisture retention. It dries out really easily, though it's pretty decent for fruit and vegetable cultivation. Clayey soil is the opposite. It's more than 2/3 clay. Tiny, fine particles, small air spaces. It retains moisture incredibly well, getting super sticky when wet and forming deep cracks when it dries out. And this brilliantly illustrates why clay is absolutely perfect for making pots. Finally, loamy soil. It has equal parts sand and silt, high humus, and the exact required porosity plants crave. It holds just the right amount of moisture, making it the absolute best soil for crops and gardening. Now, because loamy soil is so incredibly important for farming and crops, we need to cement its exact composition right now. Take a look at this chart. Loamy soil is exactly 2/5 sand, 2/5 silt, and 1/5 clay. So in percentages, that is 40% sand, 40% silt, and 20% clay. Do not forget this specific data point when you're writing your essay answers.
We are at the final stretch. Part 6, the 3 properties of soil. We're going to look at absorption, moisture, and percolation.
Stay focused, Beta. You're doing great. Let's check your examples and look at a really common practical textbook activity to understand absorption. Imagine setting up 2 funnels lined with filter paper, placing them over conical flasks. We fill one funnel with sand and the other with clay. Then we pour exactly 500 milliliters of water into each funnel. We wait a few minutes, and then we measure how much water actually drops down into the flasks below. Let's move to the next slide and see how this builds.
Grab your pens, because there is guaranteed step marking for this math formula in your exams. To find A, which is the amount of water absorbed by the soil, you take the initial water, in our experiment, 500 milliliters, and you simply subtract the final water collected in the flask. Easy, right? Then, to find the percentage absorbed, you divide that A by the total volume taken and multiply by 100. If we look at our experiment, we'll see that much less water drops through the clay funnel. Why? Because clay has a much higher water absorption tendency than sand.
All right, let's quickly cover our final 2 properties, soil moisture and percolation rate. If you take a little bit of soil and heat it in a test tube, you'll actually see tiny water droplets condensed near the top. That is soil moisture. Knowing this helps a farmer determine exactly when their field needs to be irrigated. Percolation rate, on the other hand, is the rate at which water actually exits or drains through the soil. If a soil is well drained, percolation is rapid. But if it has a poor percolation rate, it holds on to too much water for way too long, which can actually drown and harm the plant roots. So, I want to leave you with this final, provocative question to really test your critical thinking. If you had to step outside and grow your own crops tomorrow, how would climate, weathering, and porosity dictate your success? Think carefully about how all these factors connect. My dear students, it has been an absolute joy guiding you through this chapter today. To make sure your concepts remain 100% crystal clear for the exam,
Hello, class. Welcome to your 7th Standard Science Masterclass. I'm your host and your science teacher for today, and we are going to completely demystify the chapter on soil dynamics. My ultimate goal here is simple. I want you to understand every single concept perfectly, remember it easily, and absolutely crush your exams. So, sit up straight, get your mental notes ready, and let's master this topic together in today's explainer. Okay, here is our quick agenda for today. We'll cover the soil percolation experiment, crop suitability and fertility, soil erosion, soil pollution, and then we'll wrap the whole thing up with a chapter summary and your essential keywords. Let's dive right into Section 1, the soil percolation experiment. This is a highly testable area, so pay close attention. Now, before we get to the lab stuff, I want you to think about this. What actually happens when a heavy rain falls on a cemented courtyard versus your garden soil? Well, cement has practically zero porosity, meaning those tiny empty spaces for water to slip into just aren't there. So the water just runs off or creates puddles. But soil is highly porous, so it absorbs that water beautifully. To scientifically measure this absorption, which by the way is called percolation, we follow 4 specific steps. You dig a hole, insert a plastic pipe, and fill 3/4 of it with different soil samples, like clay, sand, and loam. Then, you pour a precise amount of water into that top 1/4 of the pipe. The absolute most important step here, you grab a stopwatch and note the exact time it takes for all that water to disappear into the soil. When you are recording this data for your exam, you absolutely must track 3 specific variables for every sample. You need the volume of water poured, which we call W1, the exact start time, T1, and the end time when the water is totally absorbed, T2. Setting your data up clearly like this is exactly what gets you those top marks. Listen up, class. Put a massive star next to this formula because it is guaranteed to be on your test. The percolation rate equals the amount of water in milliliters divided by the percolation time in minutes, or simply W1 over T2 minus T1. And the main scientific takeaway here is that percolation rate is inversely proportional to the time taken. Basically, if the soil takes forever to absorb the water, its percolation rate is super low. If it drinks it up quickly, high percolation rate. All right, moving swiftly on to Section 2, crop suitability and fertility. Let's see how all of this applies to Indian agriculture. You need to memorize these specific states. Wheat is largely grown in Punjab, Uttar Pradesh, and Haryana. Rice, that's massive in Punjab, Andhra Pradesh, and Uttar Pradesh. Why these places? It comes down to soil fertility, which is the soil's capacity to provide a balanced buffet of nutrients to the plants. But remember, rich soil alone isn't enough. Crops also desperately need the right mix of light, moisture, and temperature to really thrive. Now, here is a classic exam question. How do farmers fix their soil if the pH is totally messed up? It's like a seesaw. If the soil is way too acidic, you add lime, calcium carbonate to raise the pH and make it more alkaline. But if it's too alkaline, you do the exact opposite. You add peat to lower the pH and make it more acidic. Just learn them as a matching pair and you'll never get confused. Before we move on, here's a really cool bonus fact straight from the text specs box in your book. Did you know we can actually grow plants without any soil whatsoever? No way, right? It's called hydroponics. Instead of soil, the plants just chill directly in mineral nutrient solutions. It's a brilliant piece of modern agricultural science. Okay, Section 3. We are looking at a major environmental challenge, soil erosion and conservation. Soil erosion is basically the theft of our fertile topsoil by wind and running water. If your paper asks for the causes, write down these 4 specific points. 1, deforestation, because chopping down trees leaves the soil completely loose. 2, overgrazing by animals, which strips the protective grass layer. 3, floods and heavy rainfall that literally wash bare soil away. And 4, improper farming techniques, especially on hillsides where the soil is already so easy to erode. Speaking of hillsides, let's talk about terrace farming, which is one of the essential keywords for this chapter. How do we stop water from just rushing down a mountain and taking all the mud with it? We physically carve the sloping ground into massive steps, or terraces. It's an ingenious way to use basic physics to slow down the water flow. So how else do we fight back and conserve our soil? You need to know these 4 prevention measures. First, afforestation and reforestation. Simply put, plant more trees and grass. Second, controlled grazing, which means moving animal herds around so the land has time to heal. Third, building dams and mud embankments to physically block the rushing water. And finally, using that terrace farming technique we just discussed. Moving right along to Section 4, soil pollution and control. Let's see what's hurting our soil. Sadly, careless human activities create 5 main sources of soil pollution. We've got acid rain and acidic factory water poisoning the ground. We have improper dumping of raw sewage and garbage. In farming, the excessive use of harsh chemical pesticides and fertilizers is a massive issue. Then there's non-decaying waste like plastics and metals just sitting there forever. And finally, accidental chemical spills. All of this completely ruins the soil's natural fertility. But we can fix it, class, by implementing 4 sequential control measures. First, we recycle solid wastes and properly treat sewage. Second, we use animal and domestic waste to produce biogas, which is a fantastic, clean fuel. Third, we swap those harsh chemical fertilizers out for organic pesticides. And fourth, we strictly mandate that liquid factory wastes are fully treated before they ever touch the ground. And here we are at Section 5, the chapter summary and keywords. This is where we lock in that crucial scientific vocabulary. First keyword, and this is a guaranteed 1-mark question, weathering. It is the disintegration of rocks on the Earth's surface due to exposure to natural forces like wind, water, frost, and plant roots. Always remember that the continuous weathering of giant rocks is exactly how soil is created in the first place. Next is the soil profile. Imagine taking a giant knife and slicing a huge, deep section straight down into the earth. That vertical cross-section you see is the soil profile, and it shows 4 distinct layers from top to bottom. The topsoil, the subsoil, the weathered rock, and finally, the solid bedrock. To perfectly summarize this entire chapter, keep these big ideas in your head. Soil formation depends entirely on the climate, the parent rock it came from, and the slope of the land. It consists of 4 distinct layers. It comes in 3 main types based on its texture, sandy, clayey, and loamy. And because it's literally the foundation of life on Earth, we must take serious measures to avoid its erosion and pollution. All right, let's play a rapid-fire game right from your textbook. Try to shout out the answers in your head before I say them. Ready? If the soil is good for making pots, what type is it? Clayey. If it has high humus content and perfect porosity, that's loamy. And if it feels very gritty and looks pale brown, sandy. Outstanding job. Students, as your teacher, I need you to remember one golden rule. Repetition is the absolute secret to topping your class. You have every single fact, formula, and definition right here. So I encourage you to listen to this explainer anytime, again and again, while having a snack or doing a final revision right before the test. Keep listening and you won't forget a single detail. You've mastered the formulas, you know the definitions inside out, and the science of soil dynamics is completely locked into your brain. You are 100% ready to succeed. But as we finish up today, I want to leave you with this thought to ponder. If it takes nature hundreds of years to create just 1 single inch of topsoil, but only 1 violent rainstorm to wash it all away, what role are you going to play in protecting our Earth's most fragile and valuable resource? Think about that. Keep studying hard, come back to this explainer whenever you need it, and I will see you in our next class. Hello, my dear students. Welcome to class. I am your science teacher, and today we are diving into the ultimate exam masterclass explainer on Chapter 8, The Science and Composition of Soil. So sit up straight, take out those notebooks, and get your pens ready. We are going to tackle this chapter using a strict question and answer pattern. Why? Because that is exactly how you are going to memorize every single detail for your final exams. Let's get right into it. Okay, here is our syllabus for today's session. We are covering 5 massive topics. Number 1, weathering and soil formation. 2, the soil profile. 3, the 3 main soil types. 4, special properties of soil. And finally, number 5, soil erosion and pollution. Starting straight away with Section 1, weathering and soil formation, let's look at our first really important exam question. Question, differentiate between physical and chemical weathering. Write this down, beta, it's super important. Physical weathering is a mechanical breakdown. It's driven by things like freezing frost or extreme temperature changes, but it does not change the rock's original characteristics. It just breaks it apart.
Chemical weathering, on the other hand, breaks existing minerals down into completely new components. And mark my words, remember to highlight that water is the main agent causing this chemical change.
Next question. Describe the stages of soil formation. For a long answer, you absolutely must include these 3 stages in order. Stage 1, weathering breaks down the parent rock. Stage 2, microorganisms step in and add humus. Stage 3, minerals and salts seep deep down with water. Oh, and here is a guaranteed fill-in-the-blanks question for you. In which climate is soil formation the fastest? The answer is hot and moist climates. Why? Because bacterial activity is at its absolute highest there. Moving on to section 2, the soil profile. We are talking about the layers beneath our feet. Let's dig in. Think about these layers like a giant vertical slice of cake. Question, true or false? The topsoil contains partly weathered rocks. Answer, firmly false. The topsoil, or the A horizon, is very fine and packed with dark humus. It's actually the C horizon, way down near the bottom, that holds those chunky, partly weathered rocks. And please don't forget the B horizon right in the middle, the subsoil. It's compactly packed and incredibly rich in minerals. Okay, question, define humus. You must write this exact definition to get full marks on your paper. Humus is the dead and decayed plant and animal remains that significantly increase the fertility and porosity of soil. Basically, it's the magic organic ingredient that makes soil so amazing for growing things. All right, section 3, the 3 main soil types. Here is a very common objective question. Are all soils just tight and compact? Answer, entirely false. If we zoomed in really close, we'd see that different types of soils have completely different textures. It all depends on their particle sizes and their porosities. And here is your golden rule for the exam. The larger the soil particles, the larger the pore spaces between them. Memorize that. Now, this breakdown of soil types is an absolute exam goldmine. Let's do a rapid-fire check. Question. Identify the soil that is sticky when wet and forms deep cracks when it's dry. Answer. That's clayey soil, which has super fine particles and is great for making pots. Next question. Which soil is dark, flaky, and has high humus? Answer, loamy soil. It has an equal mix of sand, silt, and clay, making it perfect for cultivation and gardening. And sandy soil? Well, it has large particles, it's highly porous, pale brown, and it's simply the best for growing root vegetables and fruits. Which brings us to a classic give reasons question. Why don't we find the same crops growing everywhere across the country? Answer, because specific crops demand specific soil properties. Rice needs fine clay soil to hold and retain water effectively. Wheat, on the other hand, needs the well-drained, high-humus loamy soils, like the ones you find in Punjab and Uttar Pradesh. And root vegetables, they absolutely need sandy soil, so the large air spaces give their roots plenty of room to grow outward. Section 4, Special Properties and Fertility. Pay very close attention here, class, because we're getting into the math and chemistry of soil. Try this tricky let's apply question. Is humus content the only factor needed for plants to grow well? Answer, no. Humus is absolutely vital, sure, but plants also heavily depend on favorable light, moisture, temperature, minerals, and a somewhat neutral pH level to actually thrive. Speaking of pH, question. How do we treat soil to make it fertile if the pH is totally off balance? Do not panic, just remember this simple trick. Answer, you add lime or calcium carbonate to acidic soil to raise its pH. Conversely, you add peat to alkaline soil to lower its pH. The ultimate goal is reaching a neutral pH for optimal mineral absorption by the roots. Numerical question alert. Take your pens out right now and write this formula down. The percolation rate equals the amount of water in milliliters divided by the percolation time in minutes. Percolation is basically how fast water travels down through the soil. If it's too poor, the roots will drown. If it's too fast, the soil dries right out. Remember our golden rule? Larger particles mean larger spaces, which means a faster percolation rate. And now, Section 5, Soil Erosion and Pollution. This is our final and frankly our most crucial section for both your exams and the real world. Question. Define soil erosion and list its main causes. Answer. Soil erosion is the removal of the extremely valuable topsoil by running water and wind. But it gets so much worse when human activities are involved. Massive deforestation, improper farming techniques, and overgrazing strip the land bare. And when heavy rainfall hits that loose, bare soil, it instantly washes that precious top layer away. So, question. List the methods of soil conservation. Meticulously write these points down for your test. Number 1, afforestation and reforestation.
2. Avoiding overgrazing. 3. Building dams to control floods. 4. Constructing embankments. And please specifically highlight terrace farming. It is highly, highly tested. It's the method used in hilly areas where sloping ground is cut into physical steps to drastically reduce the speed of flowing water.
Now, do not get confused on your objective tests when they ask this. Question: differentiate between the causes and the controls of soil pollution. Remember, things like acid rain from factories, chemical spills, plastics, and improper dumping are the C causes. To control that pollution, your answer must be proper waste disposal, producing eco-friendly biogas, switching to organic pesticides, and properly treating liquid industrial waste before they reach the ground. And a quick tip. In your exam, if you get a Let's Create activity asking you to design a poster on soil pollution, use this exact powerful slogan: protect the soil, ensure our future. It brilliantly summarizes everything we've talked about today. Well, students, that brings our intense and comprehensive Chapter 8 Masterclass Explainer to a close. Have you taken good notes? Have you completely memorized the percolation formulas and the specific soil horizons to guarantee full marks on your 7th Standard Science exam? Remember, Beta, repetition is the absolute secret to scoring full marks. I strongly encourage you to listen to my teachings in this explainer anytime, again and again. Just replay this session while you review your notes until every single concept is permanently locked in your memory. You are going to do wonderfully on your exam. Keep studying hard, and I will see you in the next class.